Hello, dear friends. Good morning, everyone. So, today we are going to start with a new chapter that is lesson number 8 water. So, dear friends, as we move ahead with this chapter, firstly, let us see the introduction of this chapter. In this introduction, we are going to see why we are going to study this chapter, what we are going to study in this chapter, and how we are going to study this chapter. So, dear friends, firstly, why we are going to study this chapter? Water plays an important role in our life. This water is used for the drinking purpose by all the animals. Then, this water is also used for the irrigation purpose for plants. In industries, this water has played an important role. That means water plays an important role in our life. Everywhere water is utilized. And so, we are going to study this chapter. What we are going to study in this chapter? In this chapter of water, we are going to study about the physical properties of water, then the chemical properties of how this water reacts with various metals. These reactions of metals we are going to see how these different metals react with water. Then we are going to study what is soft water, what is hard water, how to convert soft hard water into soft water. All these things we are going to study in this chapter. And how we are going to study this chapter? We are going to study this chapter by taking the help of the reference books available, the textbook available. Then we can also take the help of Google and everything. So, dear friends, let us start with this chapter. Now, dear friends, let us see the role of water in our day-to-day life. We know that water is colorless, odorless, and a transparent compound. It's colorless, odorless, and transparent compound. This is just an introduction of this water. And now, firstly, the role of water in our day-to-day life. Water is useful to sustain life on earth. We all need water for drinking purpose. Animals require water. Plants require water. So life is present on the earth only because of this water. Now, dear friends, this water has also become an important habitat for the aquatic plants and animals. Our body consists of water, and this water is important for the circulation of various nutrients from one part of body to other parts of the body. And blood also contains water. Then this water is an important constituent of your fruits, vegetable, egg, milk, all of them contain water in appropriate proportion. Even if we call the dry fruits, they also contain some percentage of water, pulses. So that means water plays an important role in our life. Can anyone tell me what are the different sources of water? Basically, there are three main sources of water available. Three main sources of water available. The first one is rainwater, then the surface water, and the groundwater. Rainwater, surface water, and the groundwater. Rainwater, firstly, the most and the important primary source of water is the rain. The most important source of water on the earth is the rainwater. How is this rainwater obtained? Yeah, by the evaporation of water. Firstly, water undergoes evaporation. When it goes high, it undergoes slowly condensation. And when it condensates, it again comes down on the earth. So, water is obtained by the evaporation and condensation, and this cycle continues in the atmosphere. And this rainwater is free from all the solid impurities. It does not contain any solid impurities. No any soluble solid impurities are present in this water. But as the rainwater comes down, the first rain, we can call it as the first rain of the season. It contains the dissolved gases from the atmosphere, like the CO2. CO2 plus water will form H2CO3. We have seen this reaction. So it contains the dissolved gases. Then it will also contain the dissolved gases of SO2, SO3, NO2, NO3. They will form the corresponding acids. The first rain we are talking about, and it will also contain the dust particles. So the rainwater initially at the first time it contains some dissolved gases and the dust particles. Now this rainwater is obtained, most important is obtained by evaporation and condensation. This continuous process is called as the water cycle. It's called as the water cycle. Next one, or the next source of water is the surface water, available in the form of oceans, seas, rivers, lakes, ponds, etc. And this water, that is the surface water, is around 70% available on the earth. 70%. And now these oceans and rivers and lakes, all this water, this is also an important source of water because this water undergoes evaporation. This water undergoes evaporation. Your seawater and the ocean water, it approximately contains around 3.5% of soluble salts. 3.5% of soluble salt, and therefore this water is also salty, which is unfit for drinking purpose, not good for drinking purpose. This 70% of water available on the earth in the form of oceans and the seas contain 3.5% of the dissolved salts, soluble salts, which makes it unfit for drinking purpose. And so what is done? The salts are removed from this water. The salts are removed from the seawater and ocean water, and this process of removal of salts from the seawater and ocean water is called as the desalination. Is called as the desalination. So you have to define desalination. The process of removal of salts from seawater and the ocean water is called as the desalination. Now, when it rains, so what happens is the rainwater percolates down. It goes below the soil. It percolates through the soil and gets collected above the non-porous rocks. The non-porous rocks. The non-porous rocks do not allow this water to go down, and this water gets collected over here on the non-porous rocks, called as the groundwater. But now when this groundwater is percolating down, the soluble impurities gets dissolved in it, gets soluble in that. Impurities, salts present in the soil, they get dissolved in that. And so your groundwater contains some percentage of soluble impurities, At some places, when the level of this groundwater increases, this groundwater also comes out in the form of natural springs, So what we have seen is the water which is available on the earth's surface, it undergoes evaporation and undergoes condensation and again comes down in the form of rain. So this continuous cycle is called as the water cycle, and it is because of the water cycle that water is available on the earth. Dear friends, let us start with the physical properties of water. So as I have introduced initially, pure water is colorless, odorless, transparent. Colorless, odorless, and transparent. Now, the drinking water, the water that we drink, it has some taste, and this taste is because of the dissolved salts. Now, this water on the earth exists in three states: solid, liquid, and gas. And all the three phases, all the three states of water can be converted into one form to another form, either by supplying heat or by removing heat. Now, when you cool down water from room temperature, at 0 degrees Celsius, it freezes. It becomes a solid mass. And this temperature is called as the freezing point of water. 0 degrees Celsius, it freezes. It becomes a solid mass, called as the freezing point of water. And from room temperature, when you start heating water, the temperature rises. And at 100 degrees Celsius, it boils, called as the boiling point of water, So freezing point is 0 degrees Celsius and boiling point is, freezing point is 0 degrees Celsius and boiling point is 100 degrees Celsius. Kindly keep this in record. Dear friends, let us see the relation between boiling point of water and the pressure. Boiling point of water and pressure. Boiling point of water, that is 100 degrees Celsius, is the boiling point. This boiling point of water has direct relationship with the atmospheric pressure. Now what happens is, what is this direct relationship? As the pressure increases, the boiling point of water also increases. As the pressure increases, the boiling point of water also increases, and as pressure decreases, the boiling point also decreases. This is called as the direct relationship. Let us see one example. At our home, many a times we cook our food by using the pressure cooker, by using the pressure cooker. And you know that the pressure inside the cooker is very high. The pressure inside the cooker is very high. A lot of pressure of the vapors is there. So what happens? Because of the high pressure, as pressure increases, the boiling point increases. So will the water boil very fastly inside the cooker? No, the water will not boil very fastly, very easily due to the high pressure. It will take some time. And as it takes more and more time, the food inside the cooker will get cooked very easily and very nicely. I repeat my statement. Inside the pressure or inside the cooker, the pressure is very high. The pressure is very high. So what will happen because of this high pressure? The water will not boil easily. Its boiling point will increase. So it will not boil very easily, but it will take some time to reach the boiling point. It will take some time to reach the boiling point. And in that time period, your food will get cooked very easily. Will get cooked very easily. So that is why your food gets cooked very easily by using the pressure cooker. Now, what happens when the pressure is reduced? What happens when the pressure is reduced on this cooker or the water present in the cooker? So when pressure is reduced on this water which is present in the cooker, obviously the boiling point will also decrease. When pressure decreases or pressure is less, the boiling point is low. And so when the boiling point is low, the water inside over there will boil up very easily, very fastly. When we are on a high height, on the mountains, the pressure over there is very low. Pressure over there is very low. I have taken a vessel, I have taken a container, and I have started cooking my food in an open container. But the pressure is low, so the water will boil very easily because the boiling point is very, very low now. The boiling point will reduce a little bit. So what will happen? The water will boil fastly. It will require less time. And when it requires less time, so what will happen of the food inside? The food that we have kept in the water for cooking? Yes, as the boiling point has decreased, as the water boils very fastly, so the food will not get cooked. The food will not get cooked. So what is advised? When you go on high hills or high mountains, you need to carry the pressure cooker. So what happens because of the pressure cooker? A pressure is applied on the water inside the cooker. Pressure is applied. So due to the pressure, the boiling point of this water increases. It takes some more time for the water to boil. It requires some extra time because of this pressure for the water to boil. And in this extra time, dear friends, the food is going to get cooked easily and very nicely. So always it is advised to carry the pressure cooker when you are going on the high hills or when you are going on the mountains. Now, dear friends, what happens because of the addition of impurities to water? Impurity means anything that you are going to add. So addition of salts. When salt is added, when salt is added to water, it increases the boiling point of water. It increases the boiling point of water. Now the water, now the water will boil at a higher temperature. Water will boil at a higher temperature. So what will happen? You will have to supply more heat. You will have to supply more heat, and when you are supplying more and more heat, the food will get cooked very easily, very nicely. So that is why sometimes or many times we add salt for cooking food so that the boiling point increases and the food gets cooked very nicely. Secondly, addition of alcohol. When you add alcohol to water, its freezing point decreases. Water freezes at 0 degrees Celsius. Water freezes at 0 degrees Celsius. But if you add a little amount of alcohol to it, its freezing point decreases. It will not freeze at 0 degrees Celsius, but it will freeze at less than 0 in minus. Okay, and so it will not freeze up very easily. And so what happens is this property or this technique is used when water is added to the car radiators. Car radiators. What is the function of these radiators? The radiators keep the engine cool, keep the engine So what happens is alcohol is added to the water over there. So what happens is in the winter season, when the temperature falls around 0 degrees Celsius, the water will not freeze. The water will not freeze because due to the alcohol added, its freezing point has already decreased. So water will not freeze, and so the next day when you start your car, there will be no any problem. Next one, addition of salt to ice. Addition of salt to water and ice. What happens now when you add ice and water together? To some ice pieces, you have added salt. You have added salt, the solid salt. Now what happens is the melting point of ice goes below 0 degrees Celsius. It goes to around minus 15 degrees Celsius. It goes to minus 15 degrees Celsius. It will not melt till that. And so this mixture of ice and salt is called as the freezing mixture and is used to keep the foodstuffs freezed. Is used to keep the foodstuff freezed. Many times you must have heard that fish, they are transported from one place to another place by keeping them inside a mixture of ice and salt. So what happens? Will the ice melt over there? No. Its melting point has been decreased to minus 15 degrees Celsius. It will not be melted. And so the food will remain fresh over there. The food will remain fresh over there. Now, dear friends, high specific heat and latent heat. Firstly, let us see what is specific heat of a substance and latent heat of a substance. Specific heat of a substance is the amount of heat required by that substance. Amount of heat required by that substance to raise the temperature of its unit mass. 1 unit mass you have taken of that substance, and the heat required by that substance to raise its temperature of its 1 unit mass by 1 degree Celsius. The amount of heat required by a substance to raise the temperature of its 1 unit mass by 1 degree Celsius is called as the specific heat of a substance. You are going to raise the temperature by 1 degree Celsius of that unit mass of a substance. And latent heat of substance, the amount of heat required to change its state. To change its state is called as the latent heat of the substance. And every substance has a different but specific heat and latent heat. Every substance have a different specific heat and a latent heat, and that is the characteristic of that substance. That is characteristic of that substance. Water has a very high specific heat. So when we say water has a high specific heat, that means to rise its temperature, it will require or it will absorb large amount of heat. It will absorb large amount of heat. And also to cool down, it will have to give out large amount of heat. It will have to give out large amount of heat. So this property of water, that is, it has a high specific heat. This makes it as an effective coolant in many industries or radiators. So what happens? It absorbs large quantity of heat, but its temperature does not rises that much. But it goes on absorbing the heat, and therefore it acts as a good coolant in many of the industries, and car engines, nuclear reactors, etc., etc. So because of this high specific heat, water plays an important role as an coolant. Dear friends, the anomalous behavior of water. Before we move towards the anomalous behavior of water, let us see some examples. Dear friends, when we start cooling something, obviously what happens? It undergoes contraction. That means when we are cooling, you are removing out the heat energy. And when you remove out the heat energy, the particles lose the heat energy and they start becoming closer. When they are coming closer, you call this as a contraction. So by cooling process, there is contraction taking place. And when contraction takes place, the particles come closer, and the density increases. But what happens with water is the anomalous behavior of water. Let us see this. What happens with water? at room temperature, that may be 25, 27 degrees Celsius. Now, when you start cooling this water, it will also undergo contraction slowly, slowly, slowly. So see this water is undergoing contraction as you are decreasing the temperature. But at 4 degrees Celsius, when it reaches 4 degrees Celsius, now it will start undergoing expansion a little bit. You have started cooling from the room temperature, 25, 26, okay, 26, 25, 24, like this, 20 degrees, 10 degrees, 5 degrees, and 4 degrees. When you reach 4 degrees now, it will start undergoing expansion a little bit. The temperature is decreasing, but it is undergoing expansion a little bit. And when it reaches 0 degrees Celsius, it is in a solid state, but, but its volume is little bit much more. Volume is little bit more. So what happens is at 0 degrees Celsius, its volume is more, and therefore now the density will be less. The density will be less. And here this property is different than the other materials. The other materials, when you cool them, they start undergoing contraction, 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 more particles, and therefore density is high. Getting it? When you cool something, the other materials, it contracts, the volume decreases, and therefore density increases. Density increases. But for water, till 4 degrees Celsius, it undergoes contraction. At 4 degrees Celsius, now it will undergo a little bit expansion. And so the volume is more, density will be less. Density will be less. And so this water, when it is in an ice state, its density is less. Its density is less, and so the ice whose density is less than that of the normal water, the ice is going to float on water. The ice is going to float on water. And this property of water is called as the anomalous behavior of water. Is called as the anomalous behavior of water. So, dear friends, water and the ice is floating. The ice is floating on the top. The ice is on the top. And this ice is bad conductor of heat. This ice which is formed now is bad conductor of heat. And why this ice is formed, dear friends? Because the temperature around is too much cool. The temperature around is too much cool. And so this ice is formed. Now as this ice is bad conductor of heat, tell me, will it exchange this heat? Will it exchange this heat energy between this water and the atmosphere? No, it will not exchange the heat energy between this water and the atmospheric cold temperature. So what will happen? It will act as a barrier. It will act as a barrier between this water. What is the temperature of this water? Maybe 1 degree, 2 degree, 3 degree, 4 degree, isn't it? And the temperature around is very, very cold, 0, -1, -2, whatever it may be. But now this ice does not allow these to come in contact or exchange their energies, and therefore this water remains in the liquid state at 1, 2, 3, 4 degrees Celsius in a liquid state, and therefore your aquatic plants and animals, they can easily survive under this ice, isn't it? And this anomalous behavior of water is therefore very, very important for the survival of aquatic plants and animals. Very good, dear friends. Dear friends, this was all about the physical properties of water. Now, in the next video, we are going to start with the chemical properties of water. Till that, I give you a break of 1 minute or 2 minutes. Let's have a short break, drink some water, let's get fresh, and again join back for the second video. Yes, thank you everyone. Thank you. Bye bye.